Let's have some adventure with Chapter 6. Chapter 6. All right. So some things that we're going to continue to build on. We'll just change it a couple of ways. Not anything real difficult or tough. Yes.
Thank you.
So, I know you're excited to see everybody, but hush. Okay, normal curve. We talked about this before, right? And as far as the normal curve goes, the average and the mean, or the median and the average, straight in the center, half the data on one side, half on the other. You have standard deviations. So this is basically what we've been working on so far. Other terms that talk about standard deviations, you talk about a z-score. And a z-score is a standard deviation that can be a decimal amount away from the standard deviation. Whether if it's positive, it's to the right. If it's negative, it's to the left. So these are the things that we've talked about. And then if you use the table in the back, the z-table finds you a percent. And that's the percent of area that would be to the left of it. If you wanted to find the area to the right, you would go 1 minus whatever that percent would be, or 100% minus whatever that percent would be, to give you the percent to the right. And so these are all things that relate to the normal curve. And we're still going to continue with the normal curve, but we're going to start expanding it to what happens if we know about where the average would be. Okay, and when I say that, we know about where it would be. We don't know exactly where it would be, but about where it would be. The terminology is, because we've run multiple scenarios over and over and over again, we're able to find the average pretty easily for each scenario, whether the average moves a little bit to the right, a little bit to the left, or stays right as is. We don't know. So they use all kinds of scenarios. One they talk about is a light bulb factory. Light bulbs used often. They talk about, let's say you know that 99.7% of your light bulbs will work coming off the assembly line. You know that because you based it off of just arbitrary tests you've done on these. You're not 100% factory, but you have enough satisfaction that it works. What's one reason why companies might not go for 100%? What's one thing that's going to happen if you make 100% of your population perfect every time? What aren't you willing to part with other than your cell phone? What do you as the consumer not willing to part with? Yeah. So companies are going to run a certain amount to have a certain amount of success in their factories coming out, because if you get it to 100%, the cost of it is through the roof, and the consumer is still not willing to pay. Remember, we talked about the airbags that deployed at a certain amount of time. So these companies have figured out, it's going to cost me this for this airbag. If I get this above the cost that to make it 100%, the consumer's not willing to buy my product. Okay? And that's especially true as, you know, every couple of years a new phone comes out and population feels they need the best and fastest and brightest new phone in order to have them succeed in life. Is there anything wrong with the old phone? Well, it depends who you ask. You ask the salesman, heck yeah. Your old phone doesn't do this whole list of things. You ask the consumer, a lot of times the consumer's like, well, I needed to be the first to have it. And my friend's phone can't even do this, and this. So, because of social status, because of materialistic items, these phone companies are doing pretty well for themselves. Okay? If you did not have, let's say, the new iPhone's coming out and you have the last series of iPhone, is life going to change that much for you that this updated version is going to be that much better for you? And someone's going to give you some terminology. Oh, this has the blue gamma function ray on it that works even better than the red gamma function ray. And people are like, dude, I'm in. Okay? So let's do some terms. Population. This is 6.1. This is all your data. All the data that you can collect. Your population. A sample is a subset of the population. So if you have a whole population of whatever, if you were to take a small portion of it, a sample out of it, what you're trying to do is you're going to try and take the sample, and the sample will then apply to the entire population. If you were to take, let's talk people. If you were to collect data from 100% of the voting population, or you collect data from 100% of the population of the United States, does anyone know what it's called? Census. It happens every 10 years. Okay? Is it expensive to collect 100% of the data, or 100% of the population, or attempt to collect from 100% of the population? It does cost a lot of money. Can you pick people arbitrarily to find out what the population would want? Absolutely. Now, if I were to say, hey, I want to collect you guys, take your guys' opinions, and I want to apply it to the rest of the high school juniors and or seniors to the United States, you all might think you're a good population, which I agree with, but does this population in this classroom, are you going to have similar feelings that the kid that's going to Trenton High School in Trenton, New Jersey will have? Which the demographics of Trenton, New Jersey is 96% immigrant. You guys have the same beliefs? Do you have the same thoughts? The underlying value is procreation of the species. But do you guys have different values than somebody in some completely different rural or suburban area? Yes. Is your point of view correct? Yes. If your point of view is not correct, you know what you do? If you found some survey that went against what your beliefs were, you're going to go find another survey that's going to fall right into your beliefs and make you feel better about it. Okay? That's how goofy statistics can be. So, I was thinking about this the other day. We have our population. Whatever our population. Soon to be, you guys will all be part of the voting population, and please vote. But are there things that you believe and you can't believe somebody else would believe different than you? What do you guys think? Are there certain ideas that you have and you're just floored? One thing for me, I don't know how somebody votes for Democrat. It floors me. God, are you kidding me? Does it mean everything that I have, 100% of me, is Republican? Is everything that the Republicans Foundation belief is on? Am I 100% that way? Not necessarily. I'm not that far to the right, and some of you who are to the left might not be that far to the left. Do we have on a normal curve, what would you call those two regions out there? Shh. What would you call those two regions to the right and to the left? What would you call those two regions to the right and the left? Let's say this is a belief of something, and we sampled the population. What would those two regions to the right and to the left of that normal curve be? outliers. Okay? So, let me ask you this. Is there anything that could be said by this group here? Shh. Is there anything that could be said by this group here that's going to change this group's perception? No. What about this? What about this 68% of the population? The population that's within one standard deviation of the normal. If you're within that 68%, are you influenced a little bit more by the other side? Yeah. What are some core things that you have that you can't be swayed on? I guarantee you guys have some thoughts and ideas that no one, no matter what they say, is going to sway your idea of it. One would be your religion, for the most part. Okay? A lot of times people have a really strong core belief that no matter what is said, that belief isn't going to change. Do you agree? And I'm not trying to sway you on any type of religious phantom at all. I'm just trying to say that there is, a lot of times, a core value of your belief system cannot be changed because of the influences of other people. Okay? Now, what are some other things that might sway? Parents. Okay? What's one thing that's getting rammed down every kid in school's throat right now throughout the majority of the United States? No, not college. They swayed away from that, thank God. Standardized testing. Where you're going to test and test and test and test. I love it. Standardized testing. Does this school as a population, is this school very much for standardized testing or not? Be careful how you answer that. Of course not. The school's population, are we interested in standardized testing, yes or no? Beg to differ. SAT and ACT, heck yeah. ACT and SAT, we're all over at this school. Why is that? Because our population as a whole does really well on it. It does better than most schools in the state. We found some good work of the SAT and the ACT as far as the school goes. These new PARCC assessments and CMAS assessments, Cherry Creek High School, as a population, looks at it saying, we're already in the top of the state on SAT and ACT scores. What more do we have to prove to you that we're a good school? And that's really the underlying thought behind the school. Now, a lot of people are saying, I don't want my kid to take that test. I want them to be in the classroom instead learning. And I'm not trying to sway you one way or the other. Yeah, you had a question? Nope. Oh, just wait. Itching. Peripheral vision, saw your hand. So, is there anything at this point that somebody could tell you as a senior or a handful of juniors in here that's going to change your thought process on the CMAS or the PARCC assessment? I mean, think deep. Is there something out there that would change your feeling? Yeah.
Yeah, if it affected college.
Okay?
But it doesn't.
I understand. Now, let me throw this at you. What if, I'm just playing devil's advocate a little bit. What if you found out tomorrow that the CMAS, that the seniors, there was only about 24 seniors that showed up from the school to take back in November, was it? Was it somewhere in November, late October? I can't remember. Sure. What if you found out tomorrow that your college entrance, whether you're accepted or not at this point, is 100% based on how you did on that test? Oops. All right. What else do we know? What's gonna happen in that scenario? What's gonna happen, especially with this population in that scenario? Before, you're going to get the freak out, and then what's going to happen? Parents going to fight it? Are parents going to win? Parents in this community will probably win pretty well. Okay? So, is that good for us? Yeah. Why is it good for us? Because I will tell you guys, girls, I have been at the opposite end of the spectrum of parental involvement in school. Okay? I've been at a school where if we were to start having parent-teacher conferences where like 2 or 3 nights during each semester, your parents would come meet your teachers, I would say a large amount of your parents would choose to come to meet your teachers. Why? Because your parents are pretty well involved, or your guardians are pretty much involved in your education. I've been at the opposite end of the spectrum, sitting there at parent-teacher conferences, waiting for 4 hours and see one parent. Because no parents come. And it's because the demographics of the school I had been at a long time ago, education was maybe number 9 or number 10 on their list, maybe even lower. Education wasn't all that important. Education actually became a hindrance because that 16-year-old kid could have babysat their nieces, nephews, cousins, brothers, and sisters during the day. But on that other end of the spectrum, it's kind of nice that our kid is gone for 8 or 9 hours out of the day, because the bed that they slept in last night is actually being slept in by one of their relatives or somebody from their family while they're gone at school. Think about that. I don't know about you, but I kind of like getting into my bed knowing that it was just me that was there earlier. Get into bed with someone who's already been in, it's all warm. All right. Population mean. Population mean, we're going to use this for our mean, this for our standard deviation. If I use the sample mean is going to be x bar with this as the standard deviation. Okay? So symbolically, they're using 2 different things. Okay, so rolling a die. Rolling a die, single individual die. Does the die know what it rolled last? Nope. You continue to roll that die over and over and over again. What would you start to realize if you were to roll this die, say, 10,000 times? Would you feel if you rolled 10,000 times? That could be about the shape of your findings. Would you feel that it could be this? Probably not. Could this happen when rolling a die? You just told me the die doesn't remember what its last roll is. Could it roll of 10,000 rolls? Could it roll 9,000 ones? Does that mean the dice is broken? You go give it to your friend. You say, hey, roll this 10,000 times because you nothing better to do and record each time you roll it what you get. And your friends get something that looks like this. You get this, and your friend gets something that looks like this. Is there something wrong with the die? Okay, if you roll a die 5 times, what would the average be? I'd say the average would be right around 3.5. How do I know that? Or would it be closer to 3? If you roll it 30 times, what's your average changing to? Well, if I use the chart on the right side, my average is closer to 1. If I use the chart in the middle, my average is closer to 3.5. Is there anything wrong with the dye? Okay, so if you're sampling, you're collecting data. What's a good amount? I don't know. It depends what you're comparing. Okay? God bless you. So, creating your sampling distribution. So we're going to go back to the normal curve, this, and we're going to change it slightly. Okay? We're going to change it slightly. I still use black. So this is going to be over the square root of n, 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 over the square root of n. So I changed the standard deviations to deal with the sampling. Someone tell Sunshine she's talking too much. No.
She was talking.
Oh, now we're starting to point fingers, huh? See how she is? She starts throwing you guys under the bus. Let's blame everybody else for who's my fault. All right, so your standard deviations, we're going to start dealing with square root of n. N is the number of times you've taken a sample. Okay? It's your population. So when we're finding a random sample, take a fair chance. If you have a population of people or a population of things and you want to take a random sample of it, a random sample probably shouldn't be the first 10 in line. Or it shouldn't be, let's take the even numbers, or let's take every third, or let's take every fifth. That's a bad way to collect information. If you're going to do a random sample, you are going to set some arbitrary values to your sample, and somehow you're going to come up with randomly select a certain amount of your population. Okay? So a bad way to sample, don't collect data from your friends. Okay? Now, if you guys are getting in the car and saying, okay, where should we go eat? And someone says, let's go to the Burger King. And someone says, let's go to the Yak in the Box. You know, that's really not a way that you're going to determine what's the better of the two places. Yak in the Box has the best tacos on the planet. If you haven't had them, I suggest it. Oh, yeah. Something good about a deep fried taco. Okay? Voluntary. You guys have walked up to the store and you have the guy who's sitting there with the clipboard who is trying to walk up to people to collect information. Bad way to collect data. Is a phone call a good way to collect data? No. Well, it's getting worse and worse now. It used to be a really good way to collect data because the phone didn't ring off the hook with people trying to solicit information. Okay? How many of you actually have a home phone number? Now, I'm not talking about the thing in your pocket or in your backpack. I'm talking something plugged into the wall as a base. Yeah, I mean, how many don't? Raise your hand if you don't. I bet you in 10 years, we're going to have a flip-flop of what those hands did. Okay? So you get that random phone call on your cell phone, what do most of you do? You look to see who it is. If you don't recognize the number, you ignore it. Or you're like some of the thugs out there now. Call, why are you calling me? Hey, who's this? Sorry, dial the wrong number. Well, don't dial it anymore. Okay. You want to meet someplace? I'll meet you at this park. I'll throw an orange at you. I don't know where the accidental misdial of 10 digits results in someone, you've bothered me so much, so now I'm going to call you and act like I'm this tough guy. Yeah, who's this? This is Chris. Who's this? Huh. All right. Normal distribution. Oh, the other bad way is if you collect data if you're collecting data or sample from your data with family members, other ways might be if you had somebody you had in common. If you are at a Republican convention and you wanted to start collecting data on how people felt about, there's a drug out there called RU486. And RU486 is now known as the morning after pill to prevent a pregnancy from taking place. If you're at that Republican convention and you're trying to collect what people's feelings are on this new drug, or this drug has actually been out for about 20 years now, you're not going to get the best approach. Why? Republicans are pro-life. Now here's the contradiction. Republicans are pro-life, but they're all over the death penalty. Yeah, fry him! Like, yep. So, seems like there's a little hypocrisy there. But so if you are at a Republican convention, you're not going to get the right, you're all in the same mindset, so it's not a good way to collect the data. If you wanted to see what a whole population's feeling is, the whole population isn't all Republican, isn't all Democrat, isn't all liberal. It's a combination of everybody. Okay, so our random sample we talked about, normal distribution, central limit theorem. If the population is normal, it's a normal population, then your sample's normal. So if I have this population, and I know it's a normal population, that when I had surveyed it as a census, came out as a normal population, and then I pick my sample, that sample also should fall under a normal category. If the population is not normal, so we get this bimodal situation. If my population is not normal, the sample may be normal. Okay, so that's the key. If I have a bimodal situation, if I do start collecting a sample from my population that's not normal, it's very possible that my sample will create a normal situation. And a lot of times, if you're dealing with a sample of 30 or more, okay? So is a sample of 30 people about a United States issue a good amount of people? Might be. Depends how random it is. Okay? But this is a good sample, but if you want to fall into it being independent, meaning it's not relying on itself, you need to make sure that your sample, your N, is less than 10% of your entire population. So you're talking about close to 500 million people in the United States. So if you wanted to have a good sample, you want to have less than 10% of that in order for it to be an independent issue. If you have more than that, you're starting to approach the population itself. So again, you have your pool of people. If we pick less than 10% of the population, we have an independent test, meaning our next test that we have, do over again, this test isn't going to influence it much. Okay? And then the standard error, we've already talked about a little bit, is the standard deviation, so over the square root of the n, which is the entire population, or your sample. Okay? So a lot of times we can use this. We've talked about this on the calculator. NCDF, lower, upper, the mean, and then the standard deviation. This will change with this now. Our standard deviations are going to change. Let's hit a couple examples, see how we do, and I'll set you guys free. All right. IQ scores are normally distributed with a mean of 100. Okay? Example 1. And a standard deviation of 15. We are going to sample 5 high school students randomly. Okay? So, things that we know about this. We have mean of 100, standard deviation of 15. And our sample is 5 kids. Okay? What is the probability that one person has an IQ greater than 110? What is the probability that one person has a greater 6? Might be off the switch. Picking a random number out of an arbitrary large thing. So, we're going to use NCDF on our calculator. We're going to choose 110. What would be a good upper limit if we're using 110, a standard deviation is 15? What's far further to the right that's way more than a few standard deviations away? 250, 300? I like it. Okay? 1,000, 10,000. Okay? You just want to make sure that this is at least 4 standard deviations. Okay? And I'm making that as just an arbitrary rule because a lot of teachers will say, well, just make it 1,000. Well, don't make it 1,000 or don't make it 10,000 if this number's too big or the standard deviation's real big. So, one standard deviation above 110, or one standard deviation above this is 115, then 130, then 145, then 160. We're definitely above that here. Okay? So, this is looking for what is this population here? Okay, I don't have to go 1 minus anything to get it because the calculator with NCDF will handle it, being that this is my lower limit, 110, and I'm going above that. Okay? Then I want my mean. My mean's 100, and I want my standard deviation over my standard error. So I'm going to go 15 over the square root of 5. Okay? Graphic calculator coming up. Okay. All right. So to find the normal CDF, we go second vars. We're going to go normal CDF, which is number 2. Some of you might have a calculator. You plug it in. Some of you will do the lower limit, upper limit, standard deviation, and this. So mine allows me to just plug it in as I have it. So I'm going to do 110, comma 300, comma 100. That's what I mean. Over. Then I'm going to go 15 divided by the square root of 5. Close it. Oops. Okay. So the area to the right is 6.8%. Okay? So 6.8% of our population having an average IQ of 100, 6.8% of the population is going to have an IQ greater than 110. Okay? Kind of small? Sure. Is this just made up arbitrary stuff? Absolutely. What is the probability that one person... Oh, and actually, you know what I'm going to do here? I goofed up. We asked for what? How many people in this survey? Let me change that to 1. So I always base mine on 5. So let's change it to 1.
Wait, wouldn't it be one person out of the 5? Or is it one people?
You're just picking that one arbitrary person.
Okay.
So if I pick one person,
Yeah.
what's the probability they have a IQ better than 110? This is now 25%.
So the sample of 5 doesn't matter for this question?
No, because they just asked what is the probability that one person. We're not saying we're going to take those 5. What's the chance that one of them out of the 5? We're just going to say we have this population. I'm going to grab one person out of that.
Okay.
We gave everyone random numbers. We said, okay, random number 02316, and that person comes up. What's your IQ? We have a 25% probability that person has an IQ better than 110. All right. What is the probability that one person has an IQ lower than 85%? So, what are we changing up here? I want less than 85. So what is this? What would this change to? And what would this change to? Which one's 85?
The second one.
Second one. This is our 85. What should this value here be?
0.
0 sounds good. Okay, could I have picked 30? Would that still work?
Sure.
Okay, and again, we're talking about one person. So on the calculator, if you change your lower bound, in this case, to 0, so everything's staying the same except for I'm going to change the 100 and the 300. I'm going to change the 300 just to 0. I'll change the 100 to 85. We're still talking about one person. We're talking about the area to the left. Whoa. Yes, I did. What'd I do?
Put 110 to 0.
Oh boy. What happened there?
Yeah,
Oh, I'm adding extra. Oh man, there. What buffet? That works a little bit better. So what's the chance that I pick a person that has an IQ less than 85? We're talking about 15.9% roughly. Okay? Do the 3 assumptions apply? Is it random? Is it random? IQ score is normally distributed with a mean of 100, standard deviation 50. We are to select a sample of 5 high school students randomly. Is it random? Yes. They tell us it is. Independence is n less than 10% of the population. Okay? So if you think about Cherry Creek's population, you're talking about roughly 4,000 kids. If we round up, would our sample of 15 be less than 10%? Yeah, if we had a school of 150 kids and we were picking only 15 kids, that's 10%. So we're way less than that, just picking 5 kids. Normal, is it normal? Sample with 1, sample with 5, I'd say yes. What is the mean? The mean of x? It's 100 divided by 1, which is 100. And what is the standard deviation? It's the standard deviation over the square root of n. We've talked about it. Okay? Now, what is the probability that the group average is higher than 110? So what we're going to do on this is we're going to change because we're going to talk about all 5 people, so I'm going to go second normal. Alex, you're chatting too much. Caesar, chatting too much. You're being like the gal over there. Sunshine. Okay? So, we picked an average of like 300. You can pick 300, pick 1,000, pick 10,000. It's all going to be about the same as far as decimals go. Whoa. Comma. Then we're going to go 15 divided by the square root of 5. And this will be like that one that we worked on just a second ago. Because you have a sample of 5. So you're talking about if you had 5 people, it says what is the probability that the group average is higher than 110? So if I pick 5 people from this population, I'm talking about 6.8% of the population. That is, chances are 6.8% chance that they're going to have bigger than that. What is the probability lower than 85? We're going to do the same thing, but we're going to go to the 15 over the square root of 5 like the last one. Okay? And then example 2, it says a study of college freshmen found that the number of hours per week they spent at the university's library was normally distributed to be 5.2 hours and standard deviation 1.87. What is the probability of chosen a freshman is at the library more than 7 hours? Well, it's NCDF 7, 1,000 or 500 or 100, 5.2, 1.87 divided by square root of 1, because you're only talking about one person. Okay? What is the chance they are fewer than 4 hours? So you're going to have the NCDF. Okay. What is the probability that a randomly chosen freshman is at the library for fewer than 4 hours? So this is the important one. I'm putting 4 here. Okay? What value should go here, and could I have a negative value? Is that a good one to go with on this problem? Why not? 0 is not good. Why? Huh? I can have 0 hours, absolutely. But think about this. This says 5.2, and our standard deviation is 1.87. And if I keep taking 1.87 away, how close to 0 are we here? Pretty close. So this, I don't know if 0 is actually a good one. I might pick like -10. That's further down. Okay, you might be cutting off a little bit of area. How many decimals out should you take it? Well, if you're at 4 decimals, this one right here might have been influenced if that was 0 versus -10. And then C, what is the probability of randomly chosen group 25 freshmen spends more than 7 hours? So you're going to go 7, this could be 100, 5.2, 1.87 over square root of 1. Oh, square root of 25, because you're talking about 25 people. And then, so the first 2 were over square root of 1 because you're talking about one person. What is the probability if you choose 25? So this portion here is going to change as your sample continues to go. All right, so for the record, for a few things. Few of you need to complete this, okay? I'll be gone today from 10:30 to 1. Tomorrow, I have a meeting at 9:15. So this is Tuesday. And then at 1 to the close of school, I will be gone. So in here, so from about 10 o'clock on, I'll be in my office on Tuesday. Wednesday, I'm all over the place. I'll tell you that later. Thursday, Friday. So if you do need to finish your test, do it today. 6.1 worksheet will be checked off tomorrow. 6.1 checked off tomorrow. Have it. I will be marking it off for points. Have a great day, everybody.